Welcome to On Chemistry. In this video, we are going to see what is hybridization. It involves basics and problems. The very important thing is we are going to discuss in very detail both simple and advanced molecule with the help of 24 fully solved problems. Stay tuned. What is inside this video? First, we will see what is hybridization, why it is needed, and basics behind it. Then, hybridization versus properties. Then, step by step procedure to identify the hybridization. Then, common mistake. Then, exception in our method. Then, very important thing is 24 fully solved examples from JEE and NEET. Initially, I given a reference. This will help you to identify the hybridization. If you need it, you can take the screenshot. Use the table to identify unknown molecules. The highlighted ones, free radicals, carbenes, singlet and triplet, alene types are important. We will see all those things very shortly. First, hybridization. Why it is required? Because carbon can form different shapes. In methane, it formed tetrahedral. In ethene, it formed trigonal planar. In acetylene, it formed linear. Why three shapes for same carbon? The reason is hybridization. One more reason to know the hybridization is carbon has two unpaired electrons. As we know, the unpaired electrons can form bond. It creates the valency. But carbon can form 2 or 3 or 4 bonds. How it is happened? The reason is hybridization. We will see hybridization and basics behind it. The carbon hybridization normally involves sp, sp2, sp3. Carbon has 4 electrons. sp3 means s electron move to p orbital, form the sp3 hybridization. sp2 also same condition, but 1 electron don't get hybridized. In sp, 2 electron don't get hybridized. So hybridization happen between s and p, s and 2p orbital, s and 3p orbital. Here the unhybridized electron is important because it forms pi bonds. The more important thing is here carbon valency don't change, only bonded atoms will change. So always cross check you have valency 4. So the hybridization and shape. Hybridization sp3 means tetrahedral. Central carbon connected through tetrahedral way form 4 bonds. In sp2 hybridization, it forms trigonal planar. Middle carbon is there. 3 hydrogens are edges. In sp hybridization, carbon in the middle, 2 hydrogens are side, form linear compounds. For hybridization, this is the fact table. You should memorize this table. Hybridization you can memorize easily. It is the combination of two objects. For example, lion and elephant mean leaf ant. Similarly, s and p orbital mean sp1. S and 2p orbital mean sp2. S and 3p orbital mean sp3. sp1 mean linear 180 degree. Bonded atoms are 2. Bond is triple bond, 2 pi bond and 1 sigma bond. In sp2, it is trigonal planar structure, 120 degree. Bonded atoms are 3. Bond is double bond and 1 sigma bond. In sp3, tetrahedral shape. Angle is 109 degree, 28 minutes. Bonded atoms are 4. Bond is single bond. I strongly recommend to memorize this table to master the hybridization. Then how you find hybridization? It is easy. Just look at the bonds. If it is the double bonded carbon, then hybridization is sp2. If carbon connected with triple bond mean it is sp hybridization. So by looking at the bond, you can find the hybridization easily. Here to find the hybridization, there may be a common mistake. Suppose you have to find the hybridization of carbon 1. Here carbon 1 is connected with triple bond and single bond, but you should choose always high bond order. So only triple bond. Triple bond mean sp hybridization. So you should know the concept that you should choose higher bond order of carbon. We will see hybridization versus properties. The electronegativity of hybridized carbon is sp is higher than sp2 than sp3. Why? Because s orbital is close to the nucleus. So more s character mean more the electronegativity. If you look at sp hybridization, percentage of s is 50, sp2 mean 33.3, sp3 mean 25. So sp1 always attracts the electron, considered to be more electronegative. Simply triple bonded carbon are electronegative. Then hybridization versus bond length. Here hybridization can influence the bond length because multiple bond formation. sp3 means single bond, lengthy carbon-carbon bond. sp2 means double bond. sp means triple bond. Triple bonded carbons are close, nearby, so bond length is less. Suppose the question may come from energy mean it is reversed. sp is triple bonded carbon, so energy is higher. Then comes sp2, further sp3. So look at the question, bond order or bond length. Then most asked fact, counting the bonds. sp3 hybridization has single bond, so you can write one sigma bond. sp2 mean double bond. What are all the bonds? One sigma and one pi bonds. sp mean triple bonded carbon, which is one sigma and two pi bonds. It is the most asked fact. You should memorize this one. Then step by step procedure. How you find the hybridization? First step will be you should label the carbon. Hybridization is for carbon, so you should choose which carbon. Then check the connected bond, single, double or triple. Single mean sp3, double mean sp2, triple mean sp. Always choose the higher bond order. You will get the proper one. Then the rare case, carbon may connected with two double bond. That carbon is sp hybrid. So you should follow these steps. Find the hybridization. Here I given two examples. Those are hypothetical molecule. You can solve it step by step and find the procedure. Here exception come or chances of mistake. We seen already, but we will see very detailedly. Here you have to find the hybridization of second carbon. If you use our method, you just see double bonded carbon mean sp2 hybridization, but technically wrong. It is connected with two double bonds, so it is sp hybridization. So you should be always careful whether the carbon is connected with single double bond or two double bond. Then the interesting case, they may ask the bond order of benzene. Benzene, the electron is always rotating. It is like alternative single and double bond. If you choose the double bond, it will become single bond in a second. So always written as circling electrons. So hybridization or bond order, how you find it? Here bond order is 1.5. How mean single bond and double bond on same carbon? So adjacent carbons form double bond. So we choose 2 plus 1, which is double bond and single bond. It divided by 2 gives 1.5. So due to the resonance, bond order is 1.5, not 2. Then the rare and advanced concept, better memorize this rather than analyze it. CH3 is a radical. It has 3 bonded atoms but connected with single bond. So you should not commit a mistake as sp3 hybridization. It is sp2 hybridization. Same with carbene. Carbene can be singlet or triplet. Singlet carbene mean sp2 hybridized. Triplet carbon mean sp hybridized. It is very tricky and advanced, but better memorize and solve the problems. Now we are moving into important section, solved examples. We are going to solve 24 examples. Why so many? Because problems can give different perspective and complete understanding. So problems are best way to learn. Do solve the problem in any concepts. Now the first question is hybridization of C2 and C3 bond. Here long chain compound is given with 6 carbon, 1 alkene and 1 alkyne. You should know hybridization of C2 and C3. Here you should know IUPAC name, otherwise you cannot identify the hybridization. The common mistake is numbering. Numbering should start from alkene, not from alkyne, because numbering priority of double bond is greater than triple bond. Yes, according to IUPAC, double bond has highest priority than triple. So numbering start from alkene, not from alkyne. So if you look at it, you have C2 and C3 bond mean C2 bond is CH bond, C3 bond is CH2. Carbon connected with double bond mean it is sp2 hybridization. Single bond mean sp3 hybridization. So C2 and C3 hybridization is sp2 and sp3 respectively. The concept you have to learn here is double bond has higher priority than triple bond. Then the next example, here you have to find the molecule with higher bond length of carbon. The compounds are ethane, ethene, ethane and benzene. You should find which carbon distance has higher length. The question is on conversion of name to structure and identifying the hybridization, then the bond length. First, let us write all the structures. Ethane mean CH3, CH3. Ethene mean CH2, CH2. Ethine mean C double bond C. Benzene is straightforward. Benzene structure. To identify the bond length, you should know the hybridization. sp has short bond length because of triple bond. Here, question is on bond length. sp3 has higher bond length than sp2 and sp because sp3 is single bond, sp2 is double bond, sp is triple bond. So you should know single bonded carbon and carbon. In this structure, ethane is straightforward. 2 methyl group sp3 hybridization. If you look at the ethyl, both are sp2, double bond, distance is less. If you look at the triple bond, it is sp, bond is very short. If you look at the benzene bond order is 1.5. It is little bit higher than single bond, lesser than double bond. So our answer will be ethene. Both sp3 hybridized carbon has the highest bond length. Then the next example, The question is, in alene, C3H4 has how many types of hybridization? The question is indirect. You should know how to draw structure from the name. To solve the problem, you should know the alene structure. Alene is CH2 double bond C double bond CH2. Here three types of carbons are there. 1 and 3 are same. 2 is different. 1 is double bonded connecting carbon. It is sp2. 3 also same sp2. If you look at the middle carbon, it is interesting. It is a exception and rare. Carbon connected with two double bond. Carbon connected with two double bond mean it is sp hybridization, not sp2. So the type of hybridizations are sp2 and sp3. The concept you have to learn here is two double bonds connected with single carbon mean it is sp hybridization, not sp2 hybridization. Then the next example, number of sigma and pi bonds in pent 2 4 ion. Here IUPAC name is given, so you should know how to convert IUPAC name into structure and find the sigma and double bonds. Here pen 2 4 ion mean the number should start from double bond. Double bond has higher priority, so start from 1 2 3 4 5. 5 carbon mean pentate. Second position alkene. Fourth position alkyne. So pen 2 4 ion. Here the common mistake is count only carbon bonds but forget CH bond. So if you look at the CH bond, that is 6 CH bond. Carbon carbon bond mean 2 carbon carbon bond. So totally 8 pi bonds. If you look at the double bond, one is from 2 3 carbon, one is from 4 pi carbon. So totally you have 6 carbon hydrogen bond, 2 carbon carbon bond. So if you look at it, totally 6 carbon hydrogen bond, 2 carbon carbon bond, 1 double bond, 1 triple bond. So if you look at it, the total will be 10 sigma and 3 pi bonds. The concept you have to learn here is triple bond is practically 2 pi bonds. Then the next question, chlorine carbon chlorine bond angle in 1122 tetrachloroethene tetrachloromethane. The choices are 120 degree, 109 degree, 90 degree, 109 degree, 109 degree, 90 degree, 109 degree, 120 degree. So you should know the bond angle of the two compounds. Here to identify the bond angle, you should know the name and name to structure. Here 1122 tetrachloroethene mean alkene with 4 chlorine. Tetrachloromethane mean just methyl with 4 substitution. So alkene mean sp2 hybridized carbon. It is with the bond angle of 120 degree, and sp3 hybridized carbon bond angle of 109. So the order will be 120 degree and 109 degree. The concept you have to learn here is hybridization can change the bond angle. Then the next example, here you have 4 compounds. You should know which compound represents order of hybridization sp2, sp2, sp, sp from left to right. Here 4 compounds as A, B, C, D. You should find the hybridization and solve the problem. Here the answer is straightforward. You should know connected bond in those 4 choices. If you look at the A, the choices are all are sp because all carbons are connected with triple bond. So all are sp. If you look at the P choice, first carbon is connected with double bond, that is sp2. Second carbon also same sp2. Then triple bond sp and sp. So that would be our answer. But we should eliminate C and D. C will be double bonded carbon. So sp2, sp2. Again double bonded carbon sp2, sp2. All are sp2. That is not our answer. Then D. D, if you look at it, first carbon is single bonded sp3. Second and third is double bonded sp2. Terminal carbon is sp3. So from the choices, clearly B is our answer. sp2, sp2, sp hybridization. The concept you have to learn here is you should master the hybridization just from the structure. Then only you can answer the questions easily. Then the next question, find the hybridization of 1,3,5 carbon in the following structure. The compound has 6 carbon with one triple bond and double bond. Triple bond number as first position, double bond is in fourth position. So you should find the hybridization of 1,3,5. Here counting the bond will be our answer. Our question of interest is 1,3,5. 1 is triple bonded carbon, that is sp. 3 is single bonded carbon, sp3. 5 is double bonded carbon, sp2. So hybridization will be sp, sp3, sp2. The concept you have to learn here is you should know how to convert bonds into hybridization. That is critical for predicting the hybridization. Then the next example, which one of the following compound is more than one kind of hybridization? The compound A is 1,3-butadiene, B is acetylene, C is butane, D is 2-butene. You should know which compound has more than one kind of hybridization. The question is straightforward. You just see the bond, mark the hybridization. If you look at the A, all are connected with double bond. So hybridization is sp2, sp2, sp2. All are sp2. If you look at the B, two carbons are there. Both are triple bonded. So the hybridization is sp. Then the compound C, straight chain butane. All are single bond, sp3 carbon. So C also not our answer. If you look at the D, first carbon is single bonded sp3, second carbon and third are double bonded sp2, fourth carbon is sp3 because of single bond. So only D has two types of hybridization, sp2 and sp3. So our answer is D here. Then the interesting example, the compound formula is C8H10. The hybridization are sp3, sp3, sp2, sp3, sp2, sp2, sp and sp. You should draw the structure here. The question is actually a reverse of our concept. sp3 means single bond, sp2 means double bond, sp means triple bond. So 8 carbon, 8 hybridization is given. Just draw carbon, draw the bond, remaining you write hydrogen. So if you look at it, first is sp3 single bond, sp2, sp2, so double bond, then sp3 single bond, sp2, sp2, double bond, then sp, sp, triple bond. If you draw fill with hydrogen mean you have final compound. The concept you have to learn here is you should know the concept equally from forward as well as backward. That is hybridization to bond, bond to hybridization. Then the next example, the question is which one of the following compound has sp3 carbon in its structure. Here 4 different structures are given. You should identify the bond and identify the sp hybridization. You may wonder, there is no triple bond. How the sp hybridization? Here 4 structures are given. You will find the hybridization. If you look at the A, all are sp2 hybridized because all carbons are connected with double bond. If you look at the B, that is also with only double bond. So sp2, sp2. If you look at the C, all are double bonded carbon, but middle carbon connected with two double bond. So it is sp hybridization. That is exception in our trick. So that could be our answer. But we should eliminate D also. In D, all carbons are sp2 because all are connected with double bond. So only choice is C, middle carbon connected with two double bond. So sp hybridization. So the concept you have to learn here is carbon with two double bond has sp hybridization. Then the next question, the chlorine carbon chlorine bond angle in two compounds 1122 tetrachloroethane tetrachloromethane, two different compounds. You should know the bond angle. Similar problem we seen, but the fact here is you should know how to convert IUPAC name into structure. The compound A is ethene, that is alkene with 4 chlorine on 1122 position. So structure will be Cl2C double bond C Cl2, that is double bonded carbon, which is sp2 hybridization. Bond angle is 120. Then tetrachloromethane, 4 chlorine in carbon, only single bond. So sp3 hybridization. So bond angle is tetrahedral bond angle, that is 109 degree 28 minutes. So the bond angle of tetrachloroethene is 120, tetrachloromethane is 109 degree. Then the next example, match the list 1 with list 2. List 1 is ethane, ethene, carbon molecule, ethane. List 2 is 1 sigma bond, 2 pi bonds, 2 pi bonds, 1 sigma bond, 1 sigma bond and 1 pi bond. Here you should know the structure and hybridization and know the bonds. Ethane means CH3 that is sp3 carbon, 1 sigma bond or literally all sigma bond. Ethene means 1 alkene, that is C double bond C, 1 sigma bond and 1 pi bond. Then the carbon molecule. It is from MOT analysis, not the real molecule. It has 2 pi bonds. If you look at the ethane, it has triple bond. So sp and sp, that is 1 sigma bond and 2 pi bonds. So list 1 and list 2 can be matched with hybridization and number of bonds. Then the next example, the question is find the hybridization of A, B and C. Here allyl phenyl ether is given. A, B, C are single bonded, double bonded phenyl carbon. You should know the hybridization. Answer is straightforward. Look at the structure. Find the nature of bond. A is connected with only single bond. So it is sp3 hybridization. If you look at the B, it is connected with only double bond. So it is sp2 hybridization. C is a benzene carbon. In benzene, all are sp2 hybridized. So C also sp2. So A is sp3, B is sp2, C is sp2. The concept you have to learn here is in benzene, all carbons are sp2 hybridization. Then the next example, find the hybridization of 1, 2, 3, 4. That is the compound with 4 carbon, 2 double bonds in cumulative way. You should find hybridization of the position. Here first carbon is sp2 straightforward connected with double bond. Second carbon is tricky. It is connected with 2 double bond, so it is sp hybridized. Third carbon is sp2 hybridized. Fourth carbon is sp3 hybridized. So look at the bond, find the hybridization. The concept you have to learn here is a carbon with 2 double bond will have sp hybridization. Then the next example, the bond order of individual carbon-carbon bond in benzene. A is 1, B is 2, C is 1 and 2 alternatively, D is between 1 and 2. Here benzene is given. Benzene is tricky because double bond and triple bond alternatively placed. If you look at two carbon, it can be same time double and single bonded. So real bond will be average of single and double bond. If you look at the average, 2 plus 1 by 2 gives 1 by 5. So the bond order will be 1 and 5. The concept you have to learn here is in benzene, single and double bond alternatively placed reduce the bond order to 1.5. Then the next example, the question is which one of the following compound has hybridization of sp2 sp2 sp sp from left to right. A compound is cyanide, B compound is dialkyne, C is cumulative diene, D is butadiene. You should know which one follow the order. So we should go by the carbon, find the hybridization. In A compound, first carbon is double bonded sp2, second also double bonded sp2, third is triple bonded sp. So it is our answer, but we have to eliminate B, C, D. B, if you look at it, first carbon itself sp, second also sp, third and fourth also sp, all are sp mean that is not our answer. If you look at the C, first carbon is double bonded, second and third will be sp because both carbons are connected with two double bonds, and fourth carbon will be sp2. So that is not our answer. If you look at the D, all are double bonded connected carbon, all are sp2. So our answer will be A, sp2, sp2, sp and sp. The concept you have to learn here is the carbon connected with two double bond has sp hybridization, not sp2 hybridization. Then the next example, allyl isocyanide has A 2 sigma and 4 pi bonds, B 8 pi and 5 pi bonds, C 9 sigma and 3 pi bonds, and 2 non-bonded electron, D 9 sigma 3 pi and 2 non-bonded electron. The question, you should know the structure of allyl cyanide, then only you can find the answer. First, let us draw allyl cyanide. Here, let us go through the bonds individually. First, let us look at the triple bond, that is 1 sigma bond, 2 pi bond. 1 double bond means 1 sigma bond, 1 pi bond. 1 cc bond, 1 cn bond, both has 1 sigma bond. 5 CH bond, don't forget that. So 5 sigma bond. So totally 9 sigma bonds, 3 pi bonds. The concept you have to learn here is you should treat isocyanide NC bond has normal triple bond. Then the next question, the CH bond longest in C2H2, C2H4, C2H6, C2H2Br2. Here only molecular formula is given, so try to write the structure. That will be the main task here. First one is C2H2, it is alkyne, acetylene, C double bond C, so that is sp and sp, that has small bond length because of its triple bond. The distance between C and C is less. Then C2H4, clearly it is alkene, sp2 hybridization, double bond mean bond length is still less. Then C2H6, CH3, so sp3 hybridization supposed to be our answer, but let us eliminate D also. D is C2Br2, technically bromine in acetylene, so both are sp-sp bonds. So clearly C is our answer. sp3 hybridization has long bond length. The concept you have to learn here is bond length of sp is less than sp2, less than sp3. Then the next example, the number of sigma and pi bonds in 1 butene 3 ion. A is 5 sigma and 5 pi bonds. B is 7 sigma 3 pi bonds. C is 8 sigma 2 pi bonds. D is 5 sigma and 4 pi bonds. Here you should know how to convert name into structure and hybridization. Let us draw the structure. The common mistake will be starting number from alkyne. Here alkene, that is double bond, has higher priority than triple bond, that is IUPAC rule. So start with alkene. So first carbon double bond, third carbon triple bond. So butene 3 ion. Let us count the bonds here. You have one triple bond, one double bond, one CC bond, 4 CH bonds. Triple bond contain sigma and 2 pi bonds. Double bond contain 1 sigma, 1 pi bonds. CC single bond contain 1 sigma bond. CH bonds are 4. So totally 4 sigma bonds. So if you count it, total bonds will be 7 sigma and 3 pi bonds. So the concept you have to learn here is double bond has higher priority than triple bond in IUPAC name. Then the next example, here you have to count total number of pi bond in the structure. The linear compound is given with exocyclic double bond. 4 double bonds are there. You should count total pi bonds here. Here the question is total number of pi electron. Simply count the pi bonds. You can count the pi electron. Pi electron means one pi bond contain 2 pi electron. Here 4 pi bonds are there. So 4 multiplied by 2, 8 pi electrons. The answer is straightforward, but it is based on fundamentals. Don't get confused by the structure. Just apply the basics, find the answer. Then the next example, find the hybridization of 1 and 2 bonds. The compound is isocyanide with 2 carbon atoms. The possibilities are sp2, sp2, sp3, sp, sp, sp2, sp and sp. Here method is simple. Just look at the bond. First carbon is connected with triple bond. Triple bond means sp hybridization. Second carbon is connected with double bond. Double bond means sp2 hybridization. So sp and sp2 is our answer. The concept you have to learn here is in isocyanide also carbon is sp hybridized. Then the next example, the butadiene has only sp hybridized carbon, only sp2 hybridized carbon, both sp and sp2 hybridized carbon, sp2, sp3 hybridized carbons. So you should draw the structure, find the hybridization. The compound is 1,2-butadiene, 4 carbon, 2 double bonds together. If you look at it, it has all type of bond. First carbon is sp2, second carbon is sp because it is attached with 2 double bonds. Third carbon is sp2, fourth carbon is sp3. So it has sp, sp2, sp3. The concept you have to learn here is two double bond in same carbon has sp hybridization. Then the next question, long chain compound is given. You should find the hybridization of C2, C3, C5 and C6. So you should analyze the bond and find the hybridization. Here question is on C2, C3, C5 and C6. C2 is connected with triple bond, so sp hybridization. C3 with single bond, so sp3 hybridization. C5 with double bond, so sp2 hybridization. C6 with single bond, so sp3 hybridization. It is a basic question. If you know the bond, you know the hybridization. Then the final example, number of sp and sp2 hybridized carbon in the following compound. The compound is linear chain compound with double bond, triple bond, cyanide and carbonyl. The choices are 4 and 5, 3 and 5, 3 and 6, 4 and 6. Here the question is on sp and sp2 hybridized carbon. Sp mean triple bond carbon, sp2 mean double bond carbon. Here the question is tricky in the sense only on carbon hybridization is asked. Here if you look at it, there are 3 double bond, supposed to be 6 sp2 carbon, but 1 oxygen mean 5 sp2 carbon and 2 triple bonds are there, but nitrogen is not in question. So 3 sp carbon. So our answer is 3 sp and 5 sp2. The concept you have to learn here is you just look at the question. Hybridization is asked on carbon or any heteroatom. Now we summarize what we learned. Just look at the bond, find the hybridization. Single bond mean sp3 hybridization, double bond mean sp2, triple bond mean sp, resonating structure like benzene mean sp2, radicals mean sp2, carbene singlet mean sp2 carbon, carbenes triplet mean sp carbon. Carbon connected with two double bond mean sp carbon. Better memorize this table. Use it as reference.